Hello, this is Clayton with Aeromotive Research and Development Group. Today we're going to have a very informative presentation which is for the racing and automotive coolant system along with military applications for all-weather maintenance regarding and glycol antifreeze effects on performance, but we also have, with the problem, we have a positive solution. Now, not to be a myth buster here, but the fact of life is glycol antifreeze is not a coolant. It provides very little to no heat transfer capabilities. Actually, if you want good quality transfer, common distilled water is actually better. But you still need to have surface protection inside of it. Now, if you want to have surface protection in your system, you need to have a coolant system treatment with the latest, modern, advanced selection of each specific chemical material available. All right? And to maximize the performance of these chemistries, you have to use distilled water, as we've shown. As I stated, water alone amazingly has superior heat transfer heat transfer properties compared to virtually any other liquid cooling medium. But you still need to have the protection. All right. Now, many of the antifreeze companies, and you see them all there at the auto parts store, a lot of them are very similar, except for your specific Ford or Chrysler General Motors or Mercedes-Benz coolants. Those are a little higher end. But they all use similar types of chemicals, and for whatever reasons, they use the most economic design product to be able to sell it for the cheapest capability. That's why it's so cheap. And they use less costly base chemical materials. Now, what we want to be able to do is not have the short or long-term product performance diminish, but we want to increase the performance and efficiency to choose premium coolant system chemistry formulated for maximum results. Now, one of the solutions we're going to share with you later on is about our new bio-based antifreeze product, which does have heat transfer and performance capabilities you'll enjoy. Now, for coolant system maintenance, all right, it's usually the most forsaken and poorly maintained area in the automobile. All right, maintenance really is required every 2 years, okay, in your vehicle, and like every 30 to 50,000 miles. But for trouble-free operations, you need to routinely check out the system for its acidic levels, which we'll get into, and you need to also check and replace the coolant or antifreeze and replenish the corrosion inhibitors and treatment. But if you want to enhance it to help it live a little longer, you can use some of our Synmax water cooler concentrate. We'll talk a little bit later. All right. And you also have to check for possible situations of electrolysis, standing pressure, and other items which we've covered in our other presentations. Now, in 2010, there was a factory durability test with Ford Motor Company, and with their EcoBoost V6 turbocharged engine, and they did a 160,000 mile test. Now, this is pretty interesting for what you're going to see. So here, now you might say, Clayton, where did you get all these pictures? Well, I'm going to be honest with you. It was really top secret. Yeah, it was at the Chicago Auto Show. Okay, they tore the motor apart, and it was right in front of our face. But we were able to see these, and there's nothing 007 or secret about this. But what happened here is that after the antifreeze started to go away, they just started using some of the local water that was available to them out there in the proving grounds in Arizona, and you're going to see the effects of not having proper chemistry inside of it. All right. Now, here's you're going to see is that the water became rusty. All right. And then inside the water pump itself, the shaft and the bearing started to have rust. All right. If they maintained it properly, they wouldn't have had this problem. Also, you're going to see here on the block of the engine, okay, this is with the cylinder heads taken off. You can look into the actual cylinders themselves, okay, and you're going to see rusty minerals. And where do those rusty minerals go to? To the exhaust side, to the hottest side of the engine. Now, and then on the intake, you'll see rusty minerals that are embedded into the cylinder walls. Now, what happens is the upper cylinder and exhaust sides, this will affect the heat transfer with all the chemistry. You see how there's less on the intake side and more on the exhaust side? Why? Because all those minerals attack onto it, and it's just a compounding problem. All right. Again, you're going to see more contaminants are going to be drawn to the hottest side of the engine. That's going to be to the center and the exhaust side, and less to the inside. Now, another thing that you're going to notice in the head gaskets and in the valley is you're going to see where the head gasket started to leak. And then, I mean, fortunately, they never cleaned this motor up. They just tore it down and showed it here to the public. But the thing here is you're going to see where rust started to come through. And then when the antifreeze started to fail, you can see right through the coolant passages where it was made evident on the head gaskets. Again, on the head gaskets, and especially on the exhaust side, you can see where the coolant was breaking down. You can see over here on the left, you'll see on the head gaskets the spots, and then on the head itself, you can see where it started to leak. It started to leak, and then they probably just put regular water in. They weren't really being smart about it. And then it started, you could see it was like leaking into the exhaust side of the center cylinder. Why? Because it's the hottest part of the engine. Here we're going to talk about water alone versus glycol, all right? And some of the situations we have to look at in general is that if we go back to the last few slides that we saw, say, Clayton, could they have had the system working for 160,000 miles? Well, yes, they could have if they would have followed their own manual, their own OEM, and I don't care if it could have been a Corvette, for all I care, or a Mustang, or a Challenger, all right? The thing here is in the manual, it's going to state that you have to change your fluids. They didn't change their fluids. It's made evident, all right? They overbaked them. They overused them, and then they just started putting straight water in. That's why the entire engine was full of rust. If they would have had their proper Ford coolant in there and working properly like they should have, it wouldn't have had a problem. But let's get to back to where we're going to go. When the OEM designs the coolant system, in other words, the size of the radiator, it's designed for 50-50 glycol water mixture, and it's going to perform at probably the most minimum capability. If you want to increase the capability for your system to be able to have a qualified situation for transferring the heat, like we're going to get into in a minute, you do that by improving the chemistry that's used within the system. All right? So that's what we're going to get into right now. How to improve the heat transfer performance versus the current glycol that you have right now. All right? Well, let's understand what heat transfer is about. Okay, heat transfer is what's called convection. Now, convection definition. Now, you have to look at some of our other presentations to understand what we're talking about here. But heat convection is the transference of heat energy, in other words, BTUs, British thermal units, from a fluid by the actual movement or transfer of heat molecules. You're moving molecules from one place hot to another cool. Well, how do they get cool if they're from the engine? Well, that's what the radiator is for. It's to radiate the heat. It's also called for a heat transfer. Right? So what happens is the reverse. With a fluid by actual movement, cool molecules go over the hot molecules, they cool it, and then they come back. Well, there you go. Now, one of the keys that we have to improve heat transfer efficiency instead of having the glycol moving around and causing acidic situations and everything is to use distilled water with a specific formulated chemistry. I say, Clayton, but my car's under warranty. I can't do anything about it. Well, you can at least put another advanced chemistry inside of it to help it. But here's what we have to remember, is a considerable amount of available energy, BTUs, or British thermal units, must be relieved from the metal combustion chamber components by heat transfer or the convection process. And as we said before, the heat transfer or convection process is performed by the coolant system dispersing the energy, BTUs, British thermal units of heat, into the atmosphere through the radiator. Now we'll quickly go through this. You have to have cool air going over the air tubes to do this. The problem in an automobile or a car is you've got radiators in front of it. You got the air conditioning unit, you got oil coolers and everything else before it gets to the radiator. Okay. Now, in a racing unit like what you see here, you actually have the oil cooler behind the radiator. In automobile, it's usually in front, so it's hard. Now, we have to share a couple of things with you right now. Okay, is that we're not here to overrun any equipment OEM, original equipment manufacturer, of anything that they've stated. These are thoughts and opinions used in racing. All right, so don't go do something that you're not supposed to. But we will say this: most of your long life or all-weather antifreeze, as explained, the acidic salts that are within the water, if you're not using distilled water, or the chemistry that's within the antifreeze, ethylene or propylene, will break down. Okay. And so if you top it off with other water, so at the beginning, to avoid the entire problem, you need to start with the balanced distilled water, okay, and like within the water cooler products. So what we're trying to say is use wisdom. It's not a one-size-fits-all. It has to be maintained. Once that glycol starts to break down, like we saw in the other videos and the other slides, it's a problem. So let's try to avoid it. Now, we're going to quickly go through this. Reasons for distilled water is because at between 130 to 140 degrees, if you do not have distilled water, the salts are going to be coming out and going into the system. Now, no matter how clean it looks, hey, it looks pretty clean, you know, all right, the minerals and salts that are within it with between 130 to 140 degrees are going to be released out. It's just like boiling a pot of water, you know, for your pasta, and then you see all this junk that gets onto the side of the pot. Well, that's exactly what happens within your cooling system. So if you need some distilled water and you can't get technical grade, just go to the supermarket and get your second best and just get the best distilled water you can lay your hands on. Now, the results, if you do not use distilled water and you just use common water and you don't use the right chemistries, you're going to have a bunch of rust and minerals within your system. Yes, even in a new car. With aluminum, you'll have corrosion. With the steel block, you'll have rust. Corrosion and acidic protection. You see, when a coolant has been left in a system for several years, it will become acidic. Why? Because of oxidization or breakdown of the glycols and acids. Now, this is a big problem with our United States military or any military. Those vehicles spend more time sitting than they do working. And then when they go to work, then it's too late because the oxidization and the acids start eating away in the coolant. And then they got to run it out in the desert, out in the Middle East, and then it just is a real problem. Also, then it promotes electrolysis. In other words, the decomposing coolant and the acids that are created from the coolant breakdown is a birthing place for voltage to start taking on. Now, we've got some seminar presentations which you can look on that regarding electrolysis. Also, more is not better. You know, 35 to 40% glycol is sufficient. It will help stability. Always make sure that you've got pH balance, and acid neutralization is very, very important. Now you can check this with a simple pH strip, you know, like used in or a meter like used in a swimming pool. The solution is to use a qualified bio-based coolant, not a standard ethylene glycol, which we'll share later. Then you will not have, all right, glycol breakdown issues that cause problem from ethylene or standard glycol bases. Now, as we mentioned before, the problem is that antifreeze alone is not as sufficient to protect against corrosion. They have just minor corrosion protections in it, such as used with ethylene glycol. During the lifetime, it forms what's called a glycolic acid, and it's beyond what the corrosion inhibitors are able to handle. That's why you're supposed to change the antifreeze as these additives become depleted at about 25,000 miles, because glycolic and acids in the system will attack the cylinder heads, the liners, the cores, the engine parts and materials like the head gaskets. One of the big things that happens is this: you can have your radiator, and especially in an older car, it'll start eating the oil cooler that's for the radiator. And then the glycol gets into the transmission fluid, goes in and destroys your $3,000 repair bill. Today, up to $8,000 on some transmissions is bad. All right. So the answer is If you're not going to maintain it, get a better product that will help you, and we'll talk about that later, right? As mentioned before, we have to protect against electrolysis. What's that? Electrolysis occurs when the coolant becomes acidic. Now, we've gone through these presentations before, and please check those out. But it's an acidic environment that releases salts, increasing the voltage and conductivity. An acidic condition, like a corrosive battery, causes coolant to carry electrical voltage. Yes, it does. Ask your mechanics. They can carry between 1 to 4 volts. It's the truth. All right? So, also static electricity. In other words, two dissimilar metals when things are rubbing together. All right? You need to be able to do this. Why? Because modern engines today have computers and sensors with fuel injected and complicated electrical environment. All right? Where the motor is used to force, as a ground, to force electrical voltage to go through the engine. It's a bad situation. So you either fix this by maintaining it or make it better with a better additive package and better coolant. Now, also in long-term maintenance, you got corrosion, which is part of modern engines. Why? Because you've got aluminum, iron, copper, tin, lead, brass, and all these different metals. Pitting. This is caused when air bubbles are within the surface due to heat. They implode and they explode. And when they explode, they make micro pieces of metal break off from the surface, forming pits and oxidization. All right? Now, you can fix this by putting inhibitors in there and other additive packages, which is available from Synmax or a qualified coolant. Another situation is for coolant system chemistry is sometimes, it doesn't reduce the freezing point of water. All right? You have to be able to use a qualified coolant system chemistry. Please maintain it and check it out. Now, if you want to use the distilled water in a qualified treatment, here we've got a radiator that was used for 2,000 racing miles. It was like brand new. All right? Here's an IndyCar radiator used in the Dallara chassis made by PWR. This had over 4,000 racing miles on it with a qualified coolant system treatment that was approved by the engine builder and for the last 5-6 years and championships since 2012. And so the thing here is that the system always staying clean and cool. This is what a qualified coolant like water cooler can do for you. Now, water cooler, which you can read, and we've got other presentations on this, it's not a glycol chemistry. Okay, it will help improve coolant system efficiency, heat transfer, protect the cylinder heads in the engine. Now, it does. If you got a bad coolant, it's not going to replace that, but it will help take your regular coolant that you have into a premium performing product. Now, if you don't want to, if you're low on your coolant, you don't know what to do, then use some of our premix. All right, as long as you've got your glycol levels correct, or you can be able to use the bio-based Aeromotive coolant if you so choose. Now, the water cooler, as we said, has been used at least for the last 5 years in championships with the IndyCar manufacturer with qualified performance, as we shared in our other presentations. Now, I know we've been here for a while. You say, Clayton, when is this going to get over? Well, here's a solution for the antifreeze product, and it's a new product that just came out. It was called Aeromotive Coolant 7. It's an antifreeze bio-based extreme duty product. It's 100% premix. This is designed for high performance requirements, military. It's designed for storage. It's environmentally safe. Your dog could lick it off the ground and it's okay. It's designed for 50,000 hours or over 500,000 miles of automotive or commercial operations. A product designed for an anti-boil of 300 degrees Fahrenheit unpressurized or antifreeze requirements down to literally 90 below in Fahrenheit. Okay? And so this is a problem solver. Or you can use your other glycol that you have to always be worried about, or you can use something that doesn't have the problems. Check it out. I think you'll be interested in it. Now, the IndyCar engine manufacturer, which has had the engine manufacturer championships for the last 5 years, since 2012, has been using this type of product within their engines during winter performance or winter requirements in the dyno. or traveling or in cold conditions, so that their $1 million engine program wouldn't freeze on them. All right. So if they can use it, I think you can too. Now, the Aeromotive coolant, which was developed in racing with proven durability over the last 5 years, is actually also designed for military, marine, and commercial automotive, gasoline or diesel, extreme duty, long life applications. So here we are at the end. This is the end of our presentation for all-weather maintenance and a solution for problems with that. If you have any questions regarding coolant system performance, please contact us. Give us an email at office@aeromotiveresearch.com, and we will help you with the best solution. Thank you, and we will see you at our next presentation.